Lesson 1.6. We are in the lesson section, and here we go. So for task 1, it says each pair of shapes is congruent, right? So these two are congruent, these two are congruent, these two are congruent, right? Right, congruent means same size, same shape. So mentally identify a transformation or a sequence of transformations that could take one shape to the other. So a transformation, the trans part means across, and the form part means shape. So across shape. So it is changing the shape in some way, okay? So how could you change the shape in some way or make a bunch of changes to the shape that could take one shape to the other, meaning that they would overlap each other perfectly? So we could look at these two circles, and how could we do that? Well, to make P land perfectly on this circle, centered at P, land perfectly on this center circle with the center Q, all we have to do is move P, point P to point Q, and this circle P would lay perfectly on top of circle Q. That would be a transformation. Okay, that's just sliding it over, right? That's one kind of a transformation. We're just sliding it. We're not changing the size or the shape. We're just sliding it. Okay? All right, let's look at task 2. All right, these two are also the same, right? We're told that they're the same, so we're trying to figure out how we could do this. Same thing, right? We could slide point A down to point C, and point B would come down and land perfectly on point D. So we would slide it downwards so that point A meets point C and point B meets point D. That's what we would do. Okay. Okay. The next one. This one's a little more complicated. So we'll come back to number 3. Let's look at number 4. Number 4 is a little bit easier. So the idea here is that if we just slide this over, if we slide this over with T joining up with N, then this would just still be sticking out this way. You follow me? So like we also have to sort of spin it a little bit. That's called a rotation. So we're going to slide it until T lands on N, and then we rotate it slightly until S matches up with M. And of course, we're using this point up here where T and N are as our pivot point, as the place where everything spins around, like the hinge, okay? Like a hinge on a door. That stays still, and everything else moves. All right, so now let's look at this one. This one's a little more complicated. So we have here, well, which letters match with which ones? Well, if I look at it, I think that point E matches with point K here, right? So I would slide it over until point E lands on point K, and then I would rotate it just like we did down here, except I would rotate it, I think, this direction, like a clock goes. Okay, that's called clockwise. If it spins this way, it's clockwise. If it spins that way, it's counterclockwise. And you can look at the clock in the corner, down at the end wall there, and you can see which way the second hand moves, and it moves this way. So if we're moving things this way, we are turning clockwise, and if we're moving this way, we are going counterclockwise. So I would move point E onto point K, and then I would rotate it clockwise until point F came down and touched point L. And when that happens, then D would automatically line up with J. Okay? All right, next one. Says here is a line M, right? There's the line, and point C that's not on the line. We're trying to use straight edge and compass tools to construct a line that's perpendicular to line M, meaning it's going to meet it at 90 degrees, and it also has to go through point C. So it's going to look something like this when we're done with it. There's going to be a line running like this. All right, so here we go. Now we've created perpendicular lines before. We've done it using, let me see if I can pull up a random page in GeoGebra. Nope, here, let's just pull up a random GeoGebra page. We've done perpendicular lines before where like we had a line segment, right? And we were like, okay, how do we create a perpendicular line? Well, we know we can create a perpendicular bisector, right, which would split this perfectly in half by looking at these two intersection points. And if we label these two intersection points and nail them down, we can draw a line that runs right through them, and it goes right through here, and this is a right angle. It also happens to be exactly halfway between A and B, right? It splits this distance perfectly in half. So if we're looking at this point right here, right, point E is exactly halfway between A and B, and it makes a right angle here. That's why it's called a perpendicular bisector, right? It's the same side, splitting it in half. All right, so where was I? Back here, yeah. Okay, so we know we can make a perpendicular line. And the way we do that is we have 2 points that are the same distance away from our target point, right? B is the same distance away from E as A is, right? This segment here is the same length as this segment here. So we're going to do the same thing. Oops, wrong one. There we go. We have to find 2 points that are exactly the same distance away from C. Well, how are we going to do that? Well, we can take advantage of the last time we did this, we had C on a line, but now it's not on the line. But we still created a random point, right? We were like, okay, we're going to just create a random point. And then we made another point on the line that was on the other side that was the same distance away. Well, guess what? I can still do the same thing here, right? If I have this circle here, I know that this intersection point right here is exactly the same distance away from C as F is. These have to be exactly the same distance apart. So let me get the intersect tool and I will label that. Oops. Missed it. Let me try again. There we go. So F and G are the same distance away from C, right? C is perfectly in the middle of those. So now if I look at this and I create a perpendicular bisector, right? Same deal as before, right? I've got F and G as my radius, and F and G are the centers of my circle. Then I have these 2 intersection points that I can use. This one right here, and this one right here. And if I draw a line through them, well, it's definitely going to be perpendicular to this line because F and G are both on this line. And it goes right through C because C was right in the middle. All right, there we go. Awesome. Okay, now we're looking at this. All right, line segment AB has a length of 1 unit. Okay, so this could be 1 inch, it could be 1 mile, it could be 1 light year, it could be 1 parsec, it could be whatever it is, right? All right. 1 kilometer, 1 meter, 1 foot, 1 yard, right? So that's the unit. That's 1 unit. Okay, great. So what do they want us to do with that? Okay, construct its perpendicular bisector and draw the point where this line intersects our original segment. Okay, so, well, we can do perpendicular bisectors. We've been doing that all the time. So we take our compass tool. All right, here's our radius, and we pick the center point on either side. There we go. Let's zoom out just a little bit so that we can see everything. There we go. All right, cool. Now, maybe zoom out a little bit more. All right, so we have these 2 intersecting points, and it wants us to, what does it say? Construct a perpendicular bisector. Okay, so we're going to do that. Let's finish that. All right, we'll label our points here. There's that one. And there's that one, all right? And then we get our line that's going to go through those 2 points, this one right here, and that one right there, right? And it says to draw the point where the line intersects our original segment. Okay, so that would be, here's our new line, and here's our original segment, so it's got to be this point right here. Let's mark that point down. Okay, now it says, how far is this new point from A? Okay, so let's see. Well, from A to B was 1, so that means that this has to be a half, right? So I'm just going to put a little name right here so that I can see that this is point X, and I'm just going to call that point X. All right, I'll move it a little bit so that it's kind of like in the right, oops, grab onto the letter. All right, there you go. So that is point X. Cool. So now we can talk about it. You'll know what I'm talking about. All right, so if AB is 1, then AX has to be a half because it's halfway. All right, great. All right, we now have 3 points drawn. Use a pair of points to construct a new perpendicular bisector that has not been drawn yet and label its intersection with segment AB. How far is the new point from A? Okay, well, if we go from A to X, right? If we go from A to X, let's make another perpendicular bisector. So again, we'll use AX as our radius, and we put one center on X and one center on A, and that gives us these two intersection points. We can draw a line. Got to be really careful if we're just going to do this straight from a line. Let's see. We get that point and that point. Great. And we have to label this new point here. How far away is this point? And we'll just call this point, Y. Y, I don't know. Third base. Okay. There you go. All right, so Y. How far away is this point from A? Well, if AB is 1, AX is a half, well, what's half of a half? Half of a half, right? 1/2 times 1/2 is 1/4. So that's 1/4, right? This would be 1, 2, 3, 4 little steps along the way, right? Okay, so that's a quarter, right? That was 1/4 away. If you repeat this process drawing new perpendicular bisectors and considering how far your point is from A, what can you say about all the distances? All right, so let's do one more just for kicks here. All right, so again, constructing our perpendicular bisector, we use A and Y as our radius. Do the same thing again, but this time we'll put the center on A. And we got these two new intersecting points. I'm going to zoom in a little bit. Can I zoom in a little bit? Let's see here. Zoom in. There we go. All right, and I'm going to use the line tool, and I'm going to get this intersecting point here and this intersecting point there, right? And if I label this new point and I say this is point, if I say that this is point Z, I don't know why that thing keeps popping up. If that's point Z, how far away is Z from A? Well, if AB is 1, AX is a half, AY is 1/4, right? Notice it's 1/1, 1/2, 1/4, and this one is going to be 1/8. Notice we're doubling each time. 1/1, 1/2, 1/4, and double 4 is 1/8. AZ is going to be 1/8. And we notice that distance is always getting smaller, right? All the distances get smaller each time if we're cutting it in half. Okay. All right, here is a line M and a point C that's not on the line. Use straight edge and compass moves to construct a line that's parallel to line M. Parallel, we've talked about this vocabulary word. If you look at the L's in parallel, they all go the same direction. So we want a line that goes the same direction as M that goes through C, right? It goes this way. All right, let's see. Are there some instructions down there? No. This is just the task that we got to do. All right. So there's a few ways to do this, okay? We want something that's the same distance away. Let's think about, I know this is going to sound weird, but let's think about a rectangle or a square, right? We have the sides that are this way, and we have the sides that are this way. Now, the sides that are horizontal, right? Let me see if I can go back here. right? If this was one side of our square, then this could be one side of our square, right? Right? And then if we did that again, we made another perpendicular bisector, but another one that goes perpendicular to this line, we could end up with a line that was going straight across. So let's see if we can do that. So first things first, we will create a point. All right, there we go. There's our point. We're doing the same exact thing we did the very first time. We create that intersect point right there. Now we can create a perpendicular bisector that goes through C. And make sure we get exactly on that point. Exactly on that point. Actually, that makes me a little nervous. I'm going to do this by hitting those intersect points first to make sure that I've got them exactly right. And then draw my line. All right. Now, if we flip our head sideways, we can see that we're trying to hit C, and it's on the line already, and we have a distance h. So check it out. I'm going to do this to find a circle that is another point that's exactly h away from C. I got a point right there. Right, now I can create a perpendicular bisector. Here we go. I'm using HJ as my radius, and HJ as my radius again. And now I have these intersect points right there and right there. So let's nail those down. You got one right there and one right. All right, let's see. I got lost here for a second. So here's this circle around H. Right? And here's this circle around J. And you see that it intersects right there. So now I'm going to use a line. And I'm going to go from K to L, and you see that it goes right through C. Now, if we move point F around, look, our line still stays parallel to M. Everything moves, but all the lines stay the same. If we had done it wrong, when we moved F, things would go haywire. Things would get all crooked and stuff. But these lines, this new line here, line KL, is parallel to line M. All right, well, that's the last of that. So down here, you go to practice tasks, or you click on this, and that'll take you to the practice tasks. And you start up here, from 11 all the way down to 19. All right, take it away.